A warm good afternoon to all industry leaders, respected jury members, and everyone present here. I'm Suprita Nanda, Head of Power Projects, Vedanta Limited, and along with me,
I am Suman Pritidarshini, Head Asset Optimization and CBM.
It's our privilege to represent Vedanta Limited in this esteemed gathering. Vedanta Aluminium Limited is India's largest producer of aluminium and a global leader in high quality and sustainable aluminium manufacturing. We are the largest single location producer of aluminium with 1.8 MTPA aluminium capacity smelter along with 3,600 megawatt power plant. With the largest production of wire rod and billet, we are supporting 50 plus countries across all continents. Vedanta Aluminium stands at the forefront of technology, operational excellence, energy efficiency, and responsible industrial growth. Our products support critical sectors such as infrastructure, automotive, aerospace, packaging, and RE power. Vedanta Aluminium Limited remains committed to sustainability, environmental stewardship, and community development. Our initiative in green aluminium, circular economy, education, healthcare, and local empowerment reflect our purpose of transforming for good and our commitment to creating meaningful impact across the region. At Vedanta Aluminium, we strongly believe in promoting women in manufacturing. In line with our chairman, Sri Anil Agrawal's vision, we are committed to building an inclusive, diverse, and future-ready workforce wherein women take up technical roles, lead complex operations, and contribute significantly to high-performing teams. Women across our manufacturing industries are not single a number. They are representing diversity, leadership in all aspects.
In line with our chairman's vision, hotline 4 of our first women-led hotline in the global aluminium industry. This hotline is entirely driven by women operators and engineers, a team that has broken stereotypes, challenged norms, and proven that operational excellence has no boundaries. With this, to build more such milestones, Vedanta launched Project Sri Shakti, our flagship initiative to bring more women into core manufacturing and technical roles under Sri Shakti. Women are trained for heavy industry operations and they are placed in core plant roles, not just support functions, and started doing 3 shifts in 3 shifts. And this is the first company in Odisha to do 3 shifts by the women.
Another milestone we have achieved through Project 𝗃𝗃, another flagship program of Vedanta Limited, wherein we have aimed empowering underprivileged communities by giving them platform to build strong career in manufacturing. The project provides the required technical training, hands-on exposure, and a supportive learning environment with a monthly stipend to help them pursue their training without any financial barriers. Through Project 𝗃𝗃, Vedanta is fostering inclusion, breaking barriers, and enabling women to lead with skill and excellence. This is our another flagship program where our entire locomotive is being driven by complete women workforce. The entire team is responsible for delivering the required targets with quality and delivery limits.
In line with today's theme, digitization and excellence in asset care, we will present some of our success stories in asset care. So, when we are talking about solution, there are some problem statement. So, earlier, maintenance was reactive, manual, and risky. So, in case of predictive maintenance, it's due to manual, time-based, and frequency-based. Safety-related risk associated with it, taking manual measurement on running equipment. and some of the equipment are not accessible due to the running condition and for some safety risk. So the solution we have implemented is IoT based predictive analysis. We have put number of sensors, nearly 1800 plus number of sensor with 350 equipment. So how this sensor is going to work and how we select this to select the equipment where we have to put. So we have taken some measure, took some critical equipment and safety unsafe equipment where inaccessible parts will be there. So from this sensor we have collected data, starting collecting data with triaxial vibration, total acceleration, temperature, noise, etc. in every 5 minutes. So what we will do with this data? Now this data is getting accumulated and faults are being managed and comes to through AI Copilot, and trained will be in live dashboard. So this live dashboard with trained, this gives syndicated report, alert notifications including diagnostics and recommendation to the user. With this, all the action has been being taken and it will save downtime. These are some examples how this is going to give how AI giving recommendation through message or alerts. So this is a case study in meal system of Vedanta where we have collected data for 3.5 years. Before implementing the sensor, it's 2 years data where we have having 170 hours of breakdown, and after implementing it, the breakdown has been reduced to 27 hours, and with this how we improved the planned maintenance and sustain and reduced our downtime. So not only predictive maintenance, all the CBM compliances we have implemented in SAP, and all the compliance from SAP through Power BI, it's live. From this we have, from last year to this year, we have improved 5 to 7% compliance improvement, and observation tracking is being recorded daily. With this, as we are talking about predictive maintenance, it will not give direct saving, but we have to calculate the ROI. So we have saved in terms of spare saving, downtime saving. If we will do some breakdown analysis, breakdown maintenance, then there are some catastrophic failures, so we need more time, so we save some manpower, and in case of production equipment, it will going to save production and energy saving. With this, in a year we have 875 plus fault detection. With this, 4800 of downtime saved, and nearly 4 crores and more loss prevention has been done. With this, some of our key successful story will be root cause analysis in SAP. Root cause analysis is a tool where this is being used in every analysis. So before that, it's manual. It's all the data and action plans are being taken in Excel. No centralized approval mechanism, and data entry error and inaccuracy is being the problems. So for the solution, developed a customized RCA flow in SAP. List of approvers are integrated directly in the dashboard. 𝗙𝗏 analysis, action plan, evidence upload, everything embedded in SAP, and all the action tracking and RCA effectiveness tracking is being done in SAP. So due to this, our outcome is reduced manual error, improved accuracy, streamlined approvals, and RCA status are being tracked, and structured RCA process and its timely execution and compliance of the RCAs. So next success story is our maintenance dashboard, and it is also integrated with SAP. And in this KPI dashboard, we are managed and track our PM compliances, PM closure in SAP, PM tax compliance, extended PM if any, then open notifications. With this Pareto analysis of breakdowns and corrective maintenance. Next is availability, breakdown frequency, breakdown duration, planned versus unplanned trend, and PM by BD trend. Everything is being trended in maintenance dashboard so that we can having the real basis data where we can analyze, we can put up with our next course of action with this. So this is our future plan. Actually, when we are talking about future, digitization, it's not just the end of our digital journey, it's only a start towards excellence. So, as we move ahead, our focus is on building fully integrated AI-driven reliability system for the entire plant. Our future plan is centered of expanding the depth and accuracy of our condition-based monitoring through advanced diagnosis technologies. And we are bringing other different NDT techniques like thermography, MCSA, oil analysis, and UT. With the additional layer of health assessment. Each of these tools will help us identify faults are not visible through vibration alone, gives us a holistic view of machine behavior. And another major step is building centralized predictive platform, a unified digital repository where all historical data, observation, recommendation, action, and trend will live together. This will help us to derive deeper predictive insight using analytics and AI. So overall, our future roadmap is very clear, moving from predictive to prescriptive reliability. So, thank you. We are open for any question.
Thank you for the presentation. I think a couple of things came very clear, but there is a little bit of confusion I wanted to clarify, if you can throw some light. I saw you have implemented this in booster fan and the ball mill. Can you tell one step back, how did you decide or how did you evaluate what should you start the project with?
Sorry?
So my question was, how did you decide which equipment do you start a project of this nature with?
Okay, I'll just answer this question. For this, we have made our risk matrix where we have give the measure points on critical equipment based on analysis. With this, some safety unsafe equipment has been selected, and with this matrix we have selected nearly 400 equipments where we have to put the sensors.
Thank you. I think you brought out the vibration-based analysis for all the rotating equipment, about 350 plus machines. Am I right? You
Yes.
said it's 350 plus. So when you do this, how have you gathered the kind of statistical information to go after, which one to be monitored regularly, and who will attend the maintenance, those kind of scenario? Does it throw up options for you? Or this is just a cloud-based data capture and then you have to see it with individual machines?
No, actually, as I told, we have created our data pool where previously we are doing vibration analysis with number of equipment. So we have selected from that pool which are the critical equipment and which equipment having its history of problems. So with this we have selected actually, based on that.
I think the question, if I understand rightly, is that, okay, you have put data sensors, you're collecting data, you have a lot of data now. How are people managing those data which are coming? Is it coming and telling you very specific issues, alerting them, or you have to keep monitoring them? What is the mechanism by which your people can handle this data?
Okay, first of all, when the data comes with this sensor, first thing the people are actually being annoyed. A lot of data, a lot of alerts coming to their in their mobiles, and this. After this, we have given some training which alerts are being to be taken, and we have done a lot of job on that, and checked and put the things together to minimize the alerts, and this is nice now streamlined, and the people are being very trained with this vibration analysis and with the messaging service with this actually.
Follow-up question on this. Is it only related to vibration analysis, or do you also collect other data to combine it to make a predictive analysis over a period of time?
Right now we are combining temperature and noise. In further course of time, we have plan of adding oil analysis and MCSA with this.
Thank you.
Thank you.